morning friends, I am back again with one more video lecture on the topic partial differentiation. The topic partial differentiation is included in the syllabus of first year engineering and science undergraduate courses. In this lecture, we will discuss one of the important topic of partial differentiation, that is homogeneous function. A function is said to be homogeneous if all its terms are of the same degree. Now let us discuss this definition with one example. Let f of xy, this is the function of two variables x and y, is equal to x square plus x times y plus y square. Now this x square, this is the first term of the given function. This product xy, this is the second term of the given function, and this y square, this is the third term and last term of the given function. Now we count the degree of each term. So this is the first term, and degree of here degree of x is 2. Now degree of x is 1 and degree of y is 1. Therefore degree of this product xy is 2. Now this is the last term and its degree is again 2. That means every term of this given function have the same degree, that degree is 2. Therefore this given function f of xy is a homogeneous function of degree 2. Now this f of xy is a homogeneous function of degree 2. Therefore by taking this x square be the common term, so this is equal to x square times, now here is 1 plus xy upon x square, that means y upon x, plus y square upon x square. So we write this as y by x whole square. We write this bracket as f of y by x because this bracket is in the form of y by x. So therefore this f of xy is equal to x square times f of y by x. If we take this y square is common, then this function can be written in the form of f of xy is equal to y square times f of x by y. And therefore we define homogeneous function again. So this is the second definition of homogeneous function. A function f of xy is said to be homogeneous, to be a homogeneous function of degree n if this f of xy is equal to x to the power n f of y by x, or this f of xy, or this is equal to y to the power n times f of x by y. This is the another definition of homogeneous function. Now we know that this is the homogeneous function of degree 2 because all its terms are of the same degree, or it can be written in the form of x square times f of y by x, or y square times f of x by y. Now here replace x by tx and y by ty. So therefore this f of xy now becomes f of tx, ty is equal to, now this x square becomes t square x square, plus this x becomes tx, y becomes ty, and this y square becomes t square y square. Now here t square be the common term, so therefore t square times x square plus xy plus y square. And therefore this is equal to this t square, and this bracket be the original function f of xy. Therefore we write here f of xy. Now this f of tx, ty is equal to t square times f of xy. So therefore this f of xy is a homogeneous function of degree 2 if this f of tx, ty is equal to t square times f of xy. Now again we define the homogeneous function based on this t test. A function f of xy is said to be homogeneous of degree n if f of tx ty is equal to t to the power n times f of xy. Now here this n is positive, negative, 0 or fraction also. Now we will check some examples whether it is homogeneous or not. This is the first example. Here function is denoted by u and this u is equal to x square plus y square upon x plus y. Now as per the t test, here this u is denoted by f of xy and f of tx ty is equal to t square x square plus t square y square upon tx plus ty. Now in the numerator t square be the common term and in the denominator t be the common term. The t square upon t times x square plus y square upon x plus y. We write this as t square upon t means t to the power 1 times f of xy. And therefore, as per the t test, this f of xy is a homogeneous function of degree 1. Now, according to definition 2, we write this function in the form of, now here x square be the common term, the answer is 1 plus y by x square upon, in denominator x be the common term, so 1 plus y by x. Now we write this whole function like this, x times f of y by x. Therefore again this f of xy is a homogeneous function of degree 1. Observe that this numerator is a homogeneous function of degree 2 because all its terms are of the same degree. Now similarly this denominator is a homogeneous function of degree 1 because again all its terms are of the same degree and therefore this complete function numerator upon denominator is a homogeneous function of degree 2 minus 1 is equal to 1 and therefore this u is a homogeneous function of degree 1. Now one another function u is equal to cos inverse x plus y upon root x plus root y. Now this u is not a homogeneous function because it is not possible to write this function in the form of f of tx ty is equal to t to the power n f of xy. Now we write this function as cos u is equal to x plus y upon root x plus root y. Now as per the definition of 3, we write this function as f of tx ty is equal to t to the power half f of xy and therefore function cos u is a homogeneous of degree half. Now as per the definition 2, by taking x be the common from the numerator and root x be the common from the denominator, x times bracket 1 plus y by x upon root x times bracket 1 plus root y by x. Now x upon root x, answer is x to the power 1 by 2. Now we write this remaining part as f of y by x and therefore according to the definition number 2, this cos u is a homogeneous function of degree half. Now we observe that this x plus y means numerator is a homogeneous function of degree 1 because all its terms are of the same degree. Similarly this denominator is also a homogeneous function of degree half because all its terms are of the same degree and therefore this whole function numerator upon denominator is a homogeneous function of degree 1 minus half means half and therefore this cos u is a homogeneous function of degree half. Now this is the third example, u is equal to log of x to the power 4 plus x square y square plus y to the power 4. Now again we will check this function is homogeneous or not. Now this given u is not a homogeneous function because it is not possible to write this function as f of tx ty is equal to t to the power n times f of xy. Therefore we modify this function by using antilog. Therefore by using antilog, this u becomes now e to the power u is equal to this x to the power 4 plus x square plus y to the power 4. Now this right hand side is a homogeneous function of degree 4 because all its terms are of the same degree. Therefore, this e to the power u is a homogeneous function of degree 4. All of you have understood this topic, homogeneous function. In the upcoming lecture, we will discuss Euler's theorem on homogeneous function. Please subscribe the channel and let me know your comments and feedback. Thank you.